Hello, welcome back to the channel. So we're solving September 8 question. It's a split linked list in parts. So we're given a head of a single linked list and an integer k. So we want to split the linked list into k consecutive linked list parts. So the length of each part should be as equal as possible. That means no two parts should have a size differing by more than one. So this may lead to some parts being null that we will see in the first example. And then the parts should be in order. So let's say we want to split 1, 2, 3 into 5 parts. Then the size shouldn't be differed by more than one. So we will have one part to be 1, 2, and then 3. And then we have the empty like no part. So as I said, this may lead to some parts being null, and that's perfectly fine, right? And the parts should be in the order of occurrence, and the parts occurring earlier should always have a size greater than or equal to the part occurring later. So let's say in this case, instead of putting an empty array or empty linked list in the beginning and then put 1, 2, 3, we want to always put the greatest size comes before anything else that's smaller size. So this is kind of clear. One thing you can do right here is that you can just create like the return type is list. So you can just create like a array list and just create a list node and then append it into it. So you can go through and find out what's the size it to be when it needs to divide by k, and you just create this new list node and then put them in. Or another way or approach is actually just have a pointer at the starting array, and then just look through the size, and then we just took that part out and then put it into your array, the array list to be returned. So today I will go through the first approach, which is creating a new part and then get that part and then just put it in here. So let's just dive into the code. I see. All right. So, well, 125. Okay, that's perfect. All right. So first of all, I'll set current equals head because I just don't want to mess up with the head, and I want to just find out the length of the linked list. So I initialize some length equals 0, and then we set wall current. Then we want to increase length by 1, and then move the pointer to the next one. So now we have a length, we can just start finding out the size, right? The size that we want it to be for each of that. So we can say size, oh my, okay, size equals to length divide by k. So we do a real division right here, like integer divisions, and then we find out the size that needed for each of them. So a problem here is, let's say this example, right? Our head, the length is actually 3, and then we want to break it to 5 parts. So 3 divided by 5 is actually 0. So that comes where we need to use the mod. So I initialize something, or like not initialize, I use a variable called remanding to be length mod k. So length mod k will give you 3, and what is important is that we can say if we still have remanding, let's say in this case 3, then we know that the first part need to be the size plus 1, and then for how many remanding it is, like remanding for now is 3, so it means the first 3 component actually need to be whatever size it is plus 1. All right, so again I set current back to head, and then I just initialize the result and count equals to 0. So what does count do is actually to see how many k I have been. So at some points, like you get this 1, 2, 3, but then the count is just like 3. So you cannot just return your final array because your array doesn't hit 5 yet. So if that's the case, you want to still put in some like empty or like linked list into that array to make it fulfill the k. That's what the count is used for. So I can say while current means we still processing, and then I will just set dummy equals to list node, and I'll set new list equals to dummy. So if remaining greater than 0 means that this part need to be size plus 1. So I can say for dash in range size plus 1. And then we want to set that this new list dot next, because this new list is actually pointing at the dummy. So we want to set this new list dot next to actually equals to a list node, which the current dot value. And then we move this new list to next, right? So we can just keep using new list. New list dot next. And then we just move the current to the next one. After this, we know that the remaining actually done already for this term. So we can just minus remaining by 1. And then when we append it to the result, we don't want to just append the dummy. We want to append dummy.next. Alright, what if we don't have remaining anymore, right? If we don't have remaining anymore, the part will just be the size itself. So I'll just write else, and I'll just copy everything here, and then paste it here. So instead of going to size plus 1, we just go to size, and then we don't need to do this remaining anymore. So I just remove this part, and then we still append dummy.next. And then at the end, we just increase the count by 1. So we can see actually there are a lot of repeating code. I mean, this part, I can just take this out. I can just take this out and actually put it here. And then since these are in the for loop, so I can actually take it out. But the other way of doing this is actually set a new variable called like new size, and then set equals to size plus 1 if remaining greater than 0, and then else size, and then you just need to do this once. Set for dash in range new size, and then do this thing. Should I try it here? All right, maybe you can try it by yourself and see if you can optimize it. But it's just help for your thought process, right? If this happen, you do this size, else do this size. But in terms of code, like quality, maybe if you're doing an interview, you can just tell the interviewer, yeah, I know how to optimize it, and then do it on the spot. But if you're doing OA, if this help, because you can just copy paste from the top, so it doesn't really hurt. All right, so now this part encounter you that you process throughout the whole linked list. So how about the part that we want to add like empty linked list into the result array to make it to 5, right? This is where the count come in, right? So we can say while count is less than k, so while count is less than k, we can I'm just doing my all style, which is link dummy equals to the list node, and then we just append. Do I still have this? All right, do this again. Append dummy.next, and then we increase count by 1. So at the end, we just need to return the result. All right, let's see. Let's run this. Let me minimize this. All right, it's accepted. So can submit it. So here, this part is just processing the length of the linked list or the head that given, and then we find the size and the remaining, how many times we do it. So this just variables, and then this part is the actual part we're processing. And then just feel free to try it to remove redundant code, and then this part is just encounter whenever we have extra spot that we need to fill, and then we just return it. All right, I hope you enjoy the video today, and I'll just keep posting so we can all learn and keep motivated. All right.